All right, guys, let's go ahead and continue with the thing that says assignment 6.9 review. We are on number 18. It says if f prime of x is sine of x to the third, and f of 1.2 is 6.25, find f of 3.6. Now, you guys remember, this is the first fundamental theorem of calculus, okay? Is that if I integrate f prime, I get from a to b, right? I get f of b minus f of a. Okay? So what this is saying is that if I integrate from 1.2 to 3.6, this function, I am going to get f of 3.6 minus f of 1.2. And we don't know what f of 3.6 is. We do know that f of 1.2 is 6.25. And this, I should be able to just go ahead and put that into my calculator. Okay, because I'm assuming this would be a calculator question because there's no way to calculate that without. Okay, so let's see here. If I do the integral from 1.2 to 3.6 of sine x to the third. Ah, shoot. I meant to go down there. There we go. dx. Okay, and I get 0.0449. Oops. 167. Okay. And then, basically, I'm just adding 6.25 over to that, right? Then I should get what f of 3.6 is. So if I say, okay, now I'm adding, oh shoot, oops, no emulators. Don't change, thank you. Okay. If I just go ahead and add 6.25, I should get 6.2949. So then at the very end, I'll round to 3 decimal places. Okay. Okay. Awesome. All right. Perfect. Okay. There we go. All right. Let's look at number 19 through 20. Okay. I've got this graph here. Just see if I can sketch this out real quick. Okay. At 2, 4, 6, 8. Okay, perfect. So that goes here and here. And this tells me that the area is 3 and the area is 1. Let me make that better because it doesn't look so good. Okay, so we'll say that the area is 3 and here the area is 1. Okay? All right. So the first thing, number 19 says, if, let's see, the graph shown is the graph of f prime. This is important, right? We talked about this before. That's the graph of f prime. Two enclosed regions have areas of 3 and 1 is shown. Use this figure. Okay, 19 says, if f of 1 is 4, find f of 5. So here's what I would do. The integral of f prime from 1 to 5, right, and I'm integrating f prime, is f of 5 minus f of 1, okay? Because, again, integral means the, 1 to 5, the integral is saying the area in the graph of f prime. Well, if I go and look at this area from 1 to 5, 3 is on top, 1 is on the bottom, so it's 3 minus 1, so this actually has an area of 2. So it's f of 5 minus f of 1, which is 4. So f of 5 is 6. Okay? All right, let's look at number 20. Number 20 says, if f of 3 is 4, find f of 1. Okay, so same idea. I'm integrating f prime from 1 to 3, and that's going to give me f of 3 minus f of 1. Okay, well, the integral from 1 to 3, guys, is just that part up here, so that's positive 3. And it tells me f of 3 is 4. And so I get negative 1 is negative f of 1, so f of 1 is 1. Okay, now a lot of, if you could probably do these in your head, and if you don't need, or, you know, possibly, if you don't need to show them work, that's fine. All right, if you're able to do that. And then here's my last one here. Okay, so this one says if f of 5 is 4, find f of 1. So I'm going to integrate from 1 to 5 f prime. So that gives me f of 5 minus f of 1. The integral from 1 to 5, this one is all that, which is 2. And it told me that f of 5 is 4. So negative f of 1 is negative 2, so f of 1 is 2. Okay, so that's kind of how the first fundamental theorem of calculus works. Okay, cool. Okay, now number 22, this has to do with the second fundamental theorem of calculus. Okay, and what this one says is basically this: the derivative, oops, here we go, the derivative of an integral is just this function inside. But I replace the x in here. So that's 2x plus 1 times the derivative of x, which is 1. And then I place this in here. So that's 2x squared plus 1. But then this one I have to multiply by, wait, hold on. That's supposed to be a third. I replace x to the third in there, so that was 2x to the third plus 1. And then I multiply that by 3x squared, because that's the derivative of that. Okay? Okay, nice. Let's see what we got on the back. Anti-differentiate, you guys. Anti-differentiate just means take the integral. So the integral of e to the x squared plus 5x and dx. All right, this is a u subproblem. du is 2x dx, so I have a 2 1/2. So this gives me 1/2 e to the u du, which is 1/2 e to the u. So that's 1/2 e to the x squared plus 5 plus c. 24 is also an integral problem. This time, though, u is right here. Let's see. Would that give me 1 over e to the u, which is okay. That'll work. All right. So I'm going to let u be t squared minus t. So du is 2t minus 1 dt, which is perfect. When I switch this out, this becomes 1 over e to the u du, which is e to the negative u du, which is just a backwards chain, or reverse chain rule, where we just put a negative in front, plus c. So it's negative e to the negative t squared minus t plus c. Okay. Okay, nice. Let's see here. This is where we got to put on our thinking caps. All right, let's see. Okay, we got a table here. So number 26 is asking us, or number 25, sorry, is asking us to find 4 subdivisions: a right Riemann sum, a left Riemann sum, and trapezoids. Okay. 2 to 14, perfect. All right, so you guys want to look at this. From 2 to 7, that's a base of 5. 7 to 9, that's a base of 2. 9 to 10, that's a base of 1. 10 to 14, that's a base of 4. So those are my bases. If I'm using the right-hand numbers, between 2 and 7, I pick the number on the right. Between 7 and 9, I pick the number on the right. Between 9 and 10, I pick the number on the right. And between 10 and 14, I pick the number on the right. So I end up getting 15 plus 16 plus 2 minus 8. So that's 33 minus 8, that's like 25. Okay, now from the left, my bases are actually the same. But this time, between 2 and 7, I use the one on the left, 0. Between 7 and 9, I use the one on the left, 3. Between 9 and 10, I will use the one on the left, that's 8. Between 10 and 14, I use the one on the left, that's 2. Okay, so that gives me 0, 6, 8, 8. Me 22. Okay, finally my trapezoids. Now, for these, I take 1/2 and then each of these bases. So that was 5, 2, 1, 4. And then I do both heights. 0 plus 3, 3 plus 8, 8 plus 2, 2 plus negative 2. So 5 times 3, this is 15 over 2. Plus 8 is 11, the 2's cancel out. 8 plus 2 is 10, 2 goes in 5 times, and then that's 0. Okay? So that's 15 over 2 plus 16. That would be 32 over 2, so that's 47 over 2, or 23.5. All right, and so those are my 3 left, right, and trapezoids. Okay, you guys, for 26, I find, 26 and 28 easier. 27 to me is a little bit harder, but I get going from the summation notation backwards. K over n plus 2 over n. I find that a little bit easier, okay? So basically, here's what we have to fill in. All right? So here's what I'm going to do. So first of all, this number in here is going to, we're used to knowing, normally we're used to seeing these like the other way around. But anyways, that's A, okay? So A is 4. Now, this is the width of the interval. So that's the difference between the top and bottom. 4 plus 1 is 5. And then if I were to replace this thing with an x, that's what the equation is. So the equation is 3x plus 2. Okay, so that's how you can change those over. Okay, now 27, we're going the other way. This one's a little bit trickier. Plus 5x dx. Okay, so we always start this the same. Limit as n goes to infinity, n equals 1. Or, sorry, let's see, did I write? Yeah, k equals, that was supposed to be a k equals 1. There we go. Okay, limit as n goes to infinity from k equals 1 to n. So that's my number of rectangles, right? Okay, I'm going to go ahead and do the width over here. Now the width is b minus a over n, the number of rectangles. So it's 5 over n. Okay, in here, it's this function, but I replace x with a, the first number, and then k times the width of all the rectangles, 5 over n. Okay? So what I'm going to do is I'm going to take that and put that in where the x is. I'm going to need a lot more room for that. Put that all the way over. Okay. Because this equation is 2x squared plus 5x. And for the x, I need to put 2 plus k times 5 over n. I'll just put 5k over n. Okay, so that's how I do that one. And then the last one, this one's going forward, so it's a little bit easier. Limit as n goes to infinity, k equals 1 to n, cosine k pi over 3n, pi over 3n. All right? Now you know how the width is supposed to be this, pi over 3, and a is supposed to be some number in here that's added, and you guys notice that there's no number in there added to this, so it's 0 plus. So it's 0, and then the width, don't forget that 3 is part of it, because it's supposed to be b minus a over n, so b minus a has to be pi over 3, so the whole width has to be pi over 3, okay? And then what's the function of it? It's just cosine of x dx. All right, so again, going that way is a little bit easier, I think. Okay, 29. Sketch graphs and show shaded areas representing the values of each of the following. All right, so check this out here. This does not say that I can use a calculator, so let's see if I can do this without a calculator. So 1 is negative 2 to 2, x to the third plus x dx. Okay. Without the absolute value sign, x to the third plus x, if I factor out an x, goes through here, I believe. All right. So the absolute value sign would take and make this I believe look a little bit more like that. Let's see if I'm right. Okay. So let's just take x to the third plus x. Perfect. If I put an absolute value around that, see that's alpha window, and then I can put absolute value of, I get an alpha calc y1. Yeah, and it just looks like that. Okay, cool. Let's see, number 2. Oh, and then I didn't do negative 2 to 2 on this first one, so negative 2 to 2 would just be like that. Okay, 2x squared plus 5x. Sorry, what was I looking at? X squared plus 5x plus 6. Okay, x squared plus 5x plus 6. All right, you guys, that, I believe, factors, multiplies to make 6, adds to make 5 is plus 3 plus 2, which means it crosses at negative 3 and negative 2, which means that the absolute value would go like this. Okay? All right, so that's that one. And then I guess negative 2 to 2, that would just like keep going over there. Okay. X squared plus 5x minus 6. Guys, this one also factors, but this factors to x plus 6, x minus 1 to multiply to make negative 6. Which means that on my graph, it would cross at negative 6 and 1. That's a parabola. And so if I did the absolute value of that, it would go like that. Okay, you can check any of these or on Desmos or whatever you want. That's negative 2 to 2. And then my last one. Now, this is really, you guys, the only one I'd expect you to be able to do at this time, like without looking. Yeah, absolute value of x plus 1, it moves it to the left 1 from -2 to 2. Okay? It looks like that. So if we read through these statements, match each of the integrals to one of the descriptions below. A, the integral can be evaluated geometrically using area of triangles. That's this one for sure, because I just have straight lines that make up a linear absolute value, and so we can just use triangles. B, absolute value is not even necessary for the given limits of integration. That's going to be this one, and actually, I believe I messed this graph up. Hold on one second here. Okay, you guys. 1, 2, 3. It's going to cross through -2 and 3. I think I put it through -1 and 3 for some weird reason. So it's going to go like this. Okay. And then since I'm integrating it from -2 to 2, it's all over here. So that corresponds with letter B. I don't even need absolute value because even if this thing had come down here, it doesn't matter because it was all to the one side of it. Okay. Use of symmetry allows the problem to be done using only one integral that does not need absolute value. That looks like this one, because these are going to be symmetrical right here, because this is an odd function, which means that there's symmetry down there. So that when I fold it up, it's going to be symmetrical on both sides. And then D, the integral can be done by using more than one integral. The problem has to be split into two if you're going to eliminate the absolute value. That's this one. Because I had to separate it. I'd have to separate it into two different problems. Okay. For number 30, set up integrals that do not involve absolute value, which could be used to integrate, shown in 1, 2, and 3, and then evaluate in part 4 using areas of triangles. All right, check it out. So set up, but I don't actually have to solve it. All right, great. That's helpful. Okay, so for part 1 here, I'm going to do, instead of the integral from -2 to 2, I'm going to do the integral from 0 to 2 of that. X to the third plus x. So I'll do this part. And then because of symmetry, I'm just going to double it. So that's what that's saying. It's like I can just double it and I don't have to do the absolute value thing. For this one, I can literally just take off the absolute value signs because it's completely above the axis to the right of 2. So that's -2 to 2, x squared plus 5x plus 6. Okay. For number 3, I'm going to integrate from -2 to 1 because that's where it hits this. Now, when I do that on my calculator, if I take away the absolute value, it's actually going to give me what's down there. So I would need to make that negative, and then I would add on the integral from 1 to 2 of regular x squared plus 5x minus 6. Okay, so that's how I would do that one, is I just set that up into two different parts. All right, and then last but not least over here, yep, we just have two triangles. This triangle has a base of 1 and a height of 1, so 1/2 base times height. This triangle has a base of 3 and a height of 3, so 1/2 base times height. So 1/2 for that triangle, 9/2 for that triangle, so that's 10/2 or 5. Okay, and that's how we can do it without even setting up any integrals. All right, awesome. Okay. Oh, fun. All right, we're going to use a calculator for this one. Perfect. Okay, so let me show you guys a few calculator things. It wants us to find f prime of 4. It wants us to find the integral from 1 to 7 of f of x. And it wants us to solve basically f of x equals 0. And then f is discontinuous when x equals 0. Is it a whole, an asymptote, or a jump? Okay, perfect. We can use a calculator for this, so this is going to be killer. What I'm going to do, I'm going to go into my y equals, and I'm going to let this be 3x squared plus ln and then it's absolute value, so that's under alpha window, I believe. Absolute value of x. Oops. And I can actually do the derivative and the integral and everything from right inside the picture here. Okay? I didn't get the 3 in there, darn it. Hold on a sec. Insert 3, go. So fun. Okay, so let's go second calc. Let's find the derivative at 4. This was the first question. And it says the derivative is 24.25. Okay, so then right here, I'll go ahead and say that this is 24.25. The next thing it wants is the integral from 1 to 7. So I'll go calculate integral from 1 to 7. Shades it and shows me what it is. This integral is 349.621. Okay, perfect. The next thing that it wants to know is where it equals 0. So it wants to find those points. Well, those are zeros or solutions. So to calculate our zeros, let's see, I got to come all the way back over here. I have to go left, enter, right, enter, middle, enter, and I got a 0 at negative 0.488. I have a feeling that the other one is just that same number but positive, but let me just check to make sure real quick. Left, right, enter. Yep, positive 0.488. Okay, and then it tells me that there's something going on here. Is it a jump? Is it an asymptote? What? All right, now first of all, gosh, if you want to clear the integral stuff, under this draw menu, there's just something that says clear draw, so we'll start back over again. Okay, now I'm not really sure exactly what's happening there. There's a couple things we could do. We could zoom in. All right, and we could go down a little bit here, but I still can't really see what's happening. So here's what I'm thinking. I'm going to go to table set, and I'm going to put my settings at ask and then auto, and I'm going to see what's happening as I approach 1 from the left. Negative 0.1, negative 0.01, negative 0.000001. You see these numbers are just getting bigger and bigger and bigger. Let me do one more. Negative 0.0001. That's a pretty big negative number. Let's see what's happening from the other side. Okay, so from the other side, 0.1, 0.01, 0.000001. So does this kind of tell you guys what's happening? Both sides, the numbers are just getting more and more and more negative. So there's actually, at that point, a vertical asymptote. But my graph didn't really show me that. My graph just kind of showed me this, but it's because it just kept on going like that, and I couldn't really see that part. Okay? All right, cool. Easy dubs. All right, you guys, hopefully that all made sense to you. So here's this next part.